Okay, I will very quickly recall what we have discussed so far. So we started. We have the usual crowd today. We don't have really any new people, so you all understand the context. But nevertheless, we started with tokenization, and then we moved on to finding ways to represent the words. So we started with one-hot encoding and then TF-IDF. We know that it is possible, but it doesn't understand anything syntactically. Forget about semantics. Then we tried to give it some kind of meaning. So we went to CBOW, skipgram, and Word2Vec basically. And we saw that we are able to give syntactic meaning to the words, but they were localized. And then we went for a globalization, that is using GloVe. And the problem which we are facing with GloVe is that we are having a global context, but we are not able to have any kind of morphological knowledge. Morphological knowledge, what I mean is like you understand, like for supposing we have words like walk, walking, and walked. Now they're essentially the same word, but our system understands them as different words, and they create an embedding for each of the words individually. Now this has got two problems. One is that the number of tokens which we have, a number of embeddings which we have, is enormous. That is the first problem. And second thing is that it has got a huge out of vocabulary problem. Because if I come across a very strange word like breathtakingly or something like that, it will not find it in its dictionary, in its vocabulary, and it will throw a out of vocabulary error. So this is a problem. So we will try to, this problem was first solved by Facebook when they came out with the algorithm called FastText. So that is what we will discuss today. Okay. Now, sorry. So this and this problem is actually not only in English; it is more pronounced in other languages. Like for example, I've taken an example of German language. German language, you know, that is primarily very compound words. They have long words, and they are a single word which contains multiple number of words inside that. So finding strange kind of words is very common in German language. So we require a solution for that. So, so what is this? What is the solution? What Facebook came out with that Facebook first of all made a marker against the words, like these arrows that you're seeing. These are basically the beginning and end marker, and then you define a window. Like for example, I've given the example here of a 3 window. So what on a window 3, they will break down the word on a continuous basis in three alphabets. So you see here the first token is beginning marker FA, then FAS, then AST, then S. So it will break down the entire word into these components. After breaking down the word into each component, it will treat each of these components as a token. Instead of treating the entire word as a token, it will treat each of these components as a token. And then when you have so many subcomponents of the word, if a strange kind of word comes, then it can look inside the vocabulary and find out what are the components that it can put together to make the complete word. Okay, so that's how it overcomes the problem of out of vocabulary problem. So in FastText, we never have a situation where we will run out of vocabulary, because it is able to join all the complex words, join all the subwords and form a word. And here's Aditi.
Partha, does it not present the issue of efficiency because there are so many tokens now?
No, that is definitely a issue. Like if I have more number of tokens, obviously I require more amount of memory. But then the bigger thing is that I will not have the challenge of the language on the language part. I require bigger machines, but I don't have the challenge of the language part. You're right. The concern is valid. Okay.
Yes, thanks, Partha.
Okay. So so this is how it is forming. Now this technique, whatever it has developed, now this has lasted the test of time. And the modern, I discussed in the very first session regarding tokenization, where I said that we do a byte pair tokenization in the modern LLMs. Byte pair tokenization takes two pairs of bytes and sees this frequency, and then sees which are the byte pairs which are more frequent, and then it forms a token out of that. Like I give you example of what do you call a word, like let's say walk, then I will see what is the frequency of WAL. Actually it goes by pairs. First it will do WA, then AL, then WAL, and so and so. So this technique what Facebook developed, this has lasted the test of time, and it is still in utilization today. So before I move further, I will show you the whole stuff in on a Jupyter notebook how the tokenization exactly is done. So this is the function I have written to do the tokenization based on a minimum and a maximum range 3 to 6. And if I give it some English words like this, so you can see that what it will do is that I run it. So on a n-gram of 3 to 6, let it run. It is still running. Yeah, it is run. So you can see that the words are broken into tokens like this. Now, as it has got up to 6, so you can see that the largest token created is 6, and it has got many of these small tokens. So when you give it a corpus, it will break up the corpus into these tokens, and these tokens will be utilized to what do you call represent the words, and by combining them in different ways, and that will be utilized to learn the language. Okay, so if I show you the same stuff on German language, so I'm doing the same function, but in German language, so the input here are German words. So let it run. You'll see the German tokens. Okay, so you see that it is like I do not have to tell you guys that it doesn't really understand the language. It doesn't understand English or Hindi or whatever, but it just breaks it based on number of characters. And here I've given a window of 3 to 6. So based on that, it creates the tokens, and that is what the subwords are all about. Okay, so any questions do you have as of now? Yes, Aditi.
Partha, it's not strictly related to it, but okay. So let's say there is a LLM that I created today, and I trained with a certain whatever amount of data I have. When I try to train it again, let's say after some time, then I will only train it incrementally, right? I don't need to train it again because it will remember for the recurrent neural network. At least it will remember the previous thing that I have already taught, and only incrementally I will train him, right, for the rest of the data.
Not really, Aditi. The thing is that the neural network, when it is training itself, that time it remembers the past, right? But it is not across the sessions of training that it can remember.
Oh, I see. So in that case, let's say if I am training it for a certain vocabulary for a language, I will have to do that all over again when I'm training with a new data set, or let's say extended data set.
Yes, you will have to do it all over again, and
so much of memory usage. Okay,
yes.
I see that. All right.
That is a huge cost. See, when we will come to discussing on the commercials of creating a LLM, supposing you want to make it into a business, so I will discuss with you what are your recurring costs and what are your fixed costs, so that you will understand the economics. Yes, Deva.
So, Partha, what is the use of weights that have been saved? Say, for example, Meta releases the Llama model's weights. So we can use those weights, retrain the model and then use different additional data to train, right? So if we save the weights of the previous training, can I use the same weights and start from there to train with the new data?
No, yeah, actually you can do that. See, for example, I'm making this. I am making this particular English to Hindi translator. It was working fine, then it broke down because it lost some. It took a lot of time to train this. It took nearly 3 days to train this. Now, but then I lost parts of the trained model, because of which I'm having to do it once again. And now I'm not able to do it on Google Colab or on my machine, but I'm having to. I have taken AWS. It's not logged in right now. I am going to trade it on AWS and then destroy the instance. But nevertheless, I'm coming to your particular point. See, what I'm doing is that my base model is this one. I got this from Hugging Face. This is my base model. Okay. Now this base model, what Hugging Face has done is that they have already trained it. So what I'm taking from this base model is the embeddings, what they have given for Hindi language and for English language. Right. This has got both English and Hindi. So this has got the embeddings, but I cannot use these embeddings directly because I have to train the embeddings on my corpus, on the specific corpus which I'm going to be utilizing for training. So I take the base model, and then on top of this base model, I download this base model, and then on top of this base model, I do the tokenization, and I do the I'm not calling it training, I'm calling it fine tuning. So this I've set up my trainer, but then I'm not really training because I'm not going from 0 onwards. I have got some embeddings from Hugging Face. On top of that, I'm doing the training. Okay. So similarly, if I had not used Hugging Face and I had used Llama, I would have done the same thing. Now, every time Llama comes up with a update on their model, I will have to take that update and do the fine tuning of my model, which I have developed on top of that Llama model. Does it answer your question, Deva?
Yes, Partha. So in that context, if I want to reuse the existing model and train that for a specific corpus that I have, the tokenization method that I need to use will be similar to what the base model is already supporting, right? So I need to follow the same way of tokenizing, or how is that? So is that my understanding correct? So I need to make sure that tokenization method will be same as what the base model is applied on or used.
No. The thing is that tokenization is something I will not do. Like, for example, I'm showing you this example only. In this case, you see that I am not tokenizing. I am only training my model. I am taking the tokenizer as it is from the base model. You see, I'm using the tokenizer as it is from the base model. I'm not doing it on my data. Tokenization is already done.
Okay, understood. Okay.
So far we are good, right? So I have shown you the what do you call?
Quick question, Partha.
Yeah.
Okay, so now if we are taking the tokenizer from the original whatever model that you downloaded, so what is the training doing on top of the model here?
Yeah, see, the training, what it is doing is that, see here, what I told you, it is not really training, it is fine tuning, because now what it is doing is that I have taken the tokenizer and I have given my corpus to the tokenizer. So the tokenizer's logic is already fixed by the model which I have downloaded. The tokenizer will take its logic and it will make the tokens out of my corpus, out of my training data, right?
Okay.
On my training data, it will form the tokens. Those specific tokens, I will give it to the model and I will ask him to train himself to understand the language. Okay. That is a neural network which I am setting up. For example, this is a translator. Translator, what is the job of a translator, if you understand? It is to take an input and it has to give an output.
Correct.
Right. It has to take a sequence of words as an input and it has to give a sequence of words as an output. Correct? That is the work of a translator. Right. Now,
yes.
Now what I have got from Hugging Face is that I have got the tokenizer. So I have a corpus of English and Hindi text. So I will put these words, I will put these things through the tokenizer. So it will form the tokens out of my local repository which I have got for my training. After taking this tokenizer from my local repository, what it will do is that it will form a sequence to sequence. Sequence to sequence basically means that it will take an input as a sequence and it will take and produce an output which is also a sequence. So this is a sequence to sequence model which I'm trying to train. And in this training, like since you see my corpus here, I will show you my corpus, how the training happened. It's 1 minute. Yeah, you see, this is my corpus. So I have got a English, text, which is this one, and I have got the corresponding Hindi text. Okay. So similarly, I have got this English text and I have got the corresponding Hindi text. So I have got this. So like this, I have got many examples. So if you see the training size, it is 1 million items which I have got on my training list. Okay. So then, so this neural network which I am setting up, it is basically, it is saying that it is taking one English text, and then it is trying to produce a Hindi text and then comparing with this Hindi text whether he got it right or not. Right. And that is, you understand the neural network, I have to do the forward pass and backward pass. So
yes, yeah, I do. Yeah, I do.
Right.
I remember that.
So now I will take one sentence of the English text, I will do the forward pass, I will produce the output, check whether the output is correct or not. If it is not correct, I will come back and I will keep on doing this. This neural network is what I have to train. You got it?
Okay. So now it will change the embedding that you got from the base model, right?
Yes,
it will, because
yes,
okay.
Yes, definitely it will change the embeddings because this is specific to this particular token. And after the embeddings are changed, what I'm doing is I also have a validation set. If you have seen it there, so validation set. What I'm utilizing the validation set is that when the validation is not used for training, right? So when I'm validating, I'm checking what is the quality of the translation, what it is doing. So in the translation world, there is a metric called blue metric, BLUE. Okay, this blue metric basically tells what is the quality of the translation. So if you notice that it has got a number like 13.6, and ultimately after training it becomes 16.5 and all that. So the 13.6 and so the blue metric, if you notice here, it is constantly improved as the training has gone on. So that means at the end of the training, it has learned to translate much more effectively as compared to when it started. So if I had used the base model, I would have got a translation efficiency which is much lower as compared to what my fine-tuned model is giving me.
Okay.
Makes sense?
Okay, I understood. Yeah, I understood.
Yeah. Any is it clear to everyone, or anyone has any other question in this regard? Okay. Okay, now that we understood this, so first of all, we do the subword tokenization in FastText, and after now let us walk through the forward pass to understand the neural network what we are setting up. I'm doing it in the same spirit as I have done in the other models also. So I have taken a sample sentence, and on a single sentence we will do the forward pass and understand what the neural network looks like. So if you what I'm doing is that first of all I'm taking the sentence and breaking it out into tokens. So initially I have taken the different words as a token. So this is what it looks like. One minute. Okay. Now what I do is that I will try to find the context of a word. So I take my target word as playing, and I try to find whether the context word is games or not. So I just make the two words. Oh, what happened? Torch is not defined. Oh, I didn't run this. One minute. Yeah, now it is run. Okay. Next step in FastText is that I extract the subwords. So I got the subwords of both the target words and the context word which I'm showing you, and then I build the vocabulary. I put together all the subwords and I form a vocabulary. This also is clear now. Yes, Aditi.
Partha, will it like always do in the pair of 3, like the subwords, or have we defined that somewhere?
Yes, we have defined it. See,
Okay, we have
I
defined.
have said that make it minimum and
Right.
maximum 3. I can change this, right?
Okay, yeah, thanks.
Right now my corpus is very small, so that's why I've taken 3 only. Okay. Okay. Now what I do is that I change this is the first time I'm vectorizing. I first of all change my target word into vectors. So this is what is my vectors look like. This is nothing but the word index what I have created. Okay, based on the subword indexing, I've just made this tensor. Right, tensor is basically the form of vector which is utilized in neural networks. So if you are not familiar with tensor, don't worry, understand it as a vector. Now I'm saying that I want to make a embeddings of the size 6. That is my vector for the embedded text words should be 6 units long. So I'm just setting it up. So I set it. So now you see that these numbers are given by random. You understand this by now. Now you see, notice 2 things here. One is that I got the embeddings for the subwords first, because this will be important. I will be utilizing it. For every subword in my vocabulary, I got a tensor, I got a vector, and also I form the vector for every word that I have in my dictionary. Now these 2 are, and I'm assigning them randomly. Right. So this is based on my vocabulary, and this is based on my subword vocabulary. I'm just setting it up manually. Now what I do is that for the target word, I take the subwords, the subwords embeddings, and I concatenate them together. So this entire thing becomes my target subwords embedding. Now I aggregate them. I take a mean out of them. This because I cannot have so many number of vectors to represent a single word. So I will take an aggregate of this whole stuff. I will mean it across the columns, and I will get a single vector. So this is what I do here. Now if I look at, so I will have to do this in the real time for all the different words that I have. So right now I'm doing you one forward pass. So that is why I'm taking one word at a time. Okay. Now, so this is just a manual lookup. Initially, when we were doing a lookup, you know that we were doing a one-hot encoding into the embedding space. But now I can do a manual lookup because this is just a vector. Yes, Adit.
Partha, I'm a little confused about how you decided on the output vector. What is the output vector actually? If we go back a little bit.
Yeah. See, output vector is right now I'm just randomly initializing. Look here. Output vector I'm randomly initializing. I have not trained it.
So it can be any combination of words, is it, among our?
No, what are my words? You see here. I started with these words.
Right.
Right. Started with these words. Now, so this is what is my vocabulary. Right. Then now what I've done is in this FastText is that I've taken the words as it is. Right. I've taken the words and I have also taken the subwords.
Yes,
So
I understood. Yeah.
Yeah, I will show you. So right now I am giving some random embeddings to the words and the subwords, both of them. Then I will show you how I will merge the subwords to form the words. That is the next step which I am coming to.
Okay.
So you see here I had 5 words. For every word I have given a random embedding, and I had 12 subwords. For every subword I have given a random embedding. Right. The next step will be I'll have to utilize the subwords to formulate the individual words.
Okay, so basically it is all the words in your vocabulary.
Yeah, it's all the words in the vocabulary. Right now it is only randomly initialized. Okay. Okay. So say whatever I did for the target word, I will do the same thing for the context word also. So I will get a single vertical representation for the context word. This is absolutely randomized. Yeah, and you see the size is 6 because I said I want embeddings of size 6. Now what I do is I make a dot product of the target word and the context word. This is the mathematics which I'm teaching you. Make a dot product between the target word and the context word. If I do a dot product, it is both 1 by 6, 1 by 6. So it will form a single number which I denote as a score. So when I have the score, then what I can do is that I can use the sigmoid function. You know the sigmoid function, it will give me a value between 0 and 1. And if it gives me a value between 0 and 1, I can treat that as a probability, right? So I can get, because the score doesn't mean anything to me. So I will convert it into a probability, and the probability can be utilized to check whether my predictions are becoming correct or not. If the probability is high, then my prediction is correct. If it is low, then I have to go back and train once again. So I have completed my forward pass. So I see my output of the forward pass. And let us draw the neural network for this to understand this better. So you see here, you now visually understand this. So I took all my subwords, the complete dictionary of my subwords, and I put them together into a subword embedding matrix. This was done at random. Then what I did was that I produced, for each subword, I produced a representation which is at random, and I took an average of that. And this average, and what I'm doing is that I'm doing a dot product with the, this is my context word. So I took a random initialization of this, and I take my, this word playing is composed of these components of my subword dictionary. Right, these are the components into the subword dictionary. I took a mean of that to get a single vector. Then that is my hidden state, and I do a dot product with the context word to get a score, and that I'm doing a sigmoid on that score to get a probability. So this is how I get. So what I'm trying to do is that I'm seeing that whether for this target word this is the best context word or not. That is the neural network I'm trying to set up. And if I train this continuously, then ultimately it will be able to understand that given this target word, what should be the context word. So that is the whole effort, right, of the neural network. Any questions? Did you understand? Could I explain effectively today? Yes or no?
Yes, sir. But
Yes, Partha. So basically, is it going to be like something like a next word generator?
No. Right now, I'm just understanding the surroundings, right? I'm just understanding. I'm not doing any application.
And this will be done for every word and every context word in our vocabulary.
Yes, for every word, I will check against every word. That will be the neural network training which I will do. I will show that as the next step. Okay. Let's proceed. If you have any question, I can always come back. Okay. So now let us do it for the complete neural network training. I set it up. So I take my sentence. This is my sentence. There are 5 words in this. I build my vocabulary. So you see that I have my vocabulary. Did I run torch? No, I did not. Just 1 minute. Okay. Let's start again. Okay. I have this. So I sorted the words, and this is my vocabulary, and this is indexed. Now I extract the subwords. This is where the subwords are formed. For every word, I have got the subwords, right? So I can put together these subwords to form the word once again. That is what I will do. I showed you in the one pass also. Then I put all the subwords together in a single set. So this becomes my subword vocabulary. Okay. Now you see that I'm forming each word out of a subword. So this is the vector of the subwords forming the words. Is this part clear? This should be clear, right? Yes or no?
Yes, Partha.
Everyone?
Yes.
yes, sir.
Okay. Okay, now what I do is that now that I have this, I combine all the words and subwords, all the context and the play and the target words and form my training set. So this is my complete training set, right? I'm comparing each word against each other, right? After I do that, now here's a small change. What Facebook did was that these are all the positive test cases, right? This I'm getting directly from my input sentence which I gave. So children are, these are two next to each other. Are children, obviously opposite of that, are playing, and these are the positive test cases, right? For training. Now, what Facebook also introduced was something known as negative samples. Negative samples means samples where I know it is not the right target word for the right context word. So I formed that set also. So I will show you now. So take for example, this is example one. 1 minute. Where are the negative samples gone? Did I not print it? No, I did not print the negative samples, but I can show you here itself. Yeah, you see here this combination of a target word and context word. This has got a label of 1. Label of 1 means this is a positive sample, and if it has got a label of 0, that means it's a negative sample. So it will learn what are the words which are together and what are the words which are not together. Both that kind of data I'm going to utilize for training. Did you get this point? This is very important. If not, I will repeat myself.
So this negative word, that pool that you're creating, is it against the data sample that we already have? So we are trying to understand, okay, the children are playing, right? So if I take that as an input, my negative sampling is making sure that, okay, what are the combination of words that cannot exist together in the same pool of data that we are sending?
See here, it is very simple. The thing is that I made a window of 2, right? That is why you're seeing that the positive sample says, what is the sentence? Sentence is children are playing games. So children are is a positive sample, right? Are playing is a positive sample. Are children is a positive sample, right? Are playing games is a positive sample. And similarly, games playing is a positive sample. Now, if I take the word children and playing, this becomes a negative sample because they are not next to each other in my current setup, window 2.
Understood. So it is based on our own corpus. We are trying to find the combination that cannot exist together.
Yes. Now you must have realized by now, right now, I am not creating any training data manually. This is all self-supervised learning. So I'm just teaching him a particular mechanism and he's doing everything by himself, the machine. Clear?
Understood, Partha. Thank you.
Yeah. So now I have found my positive and negative samples. So this I can utilize for the purpose of training my neural network. So I have done this. Now I initialize my training parameters. The most important thing for you guys is that I require embeddings of size 6. So everything else is you can just go through. So this is the initialization. So I have given it initial vectors that these are all randomly generated. Okay. Right now it is not trained. So for the subwords and also for the words which are, I've given them random samples. So I'm saying that train was 500 epochs and calculate the loss. So it has trained and it has understood what are the combinations which of the words which work and which does not work. So now I inspect it randomly. Now you see that the words playing games, these were appearing together, right? So since these were appearing together, it has got a score of -7 and it's got a very low probability of -0075. So this can be a concern, and it is labeled is 0. That means they are together. I can let me run it up to this stage once again. Let me see whether it learns better or not. In this particular, it is possible that within 500 runs, it may not learn effectively. So if I do this once again, let me run this once again. Okay, let us see. These children are playing together, so these two are together. And you see that it is saying that this is a 31% probability that they are in the same context. Similarly, look at this games outside. This is also together, and this is giving a probability of 99.5%. Right. And the children are playing games outside. What is the word? What is the sentence? Games outside is together. Are playing is also together. Okay. So this is a positive sample. 0 means negative and 1 means positive. So this is given a high probability that these two are together. And games outside. So it is anyway. It is not learning very effectively because the same set of words it is giving two different probabilities. This can happen in neural network training. It may not learn effectively within the scope. And the corpus is very small, so we should not go by this particular output, but we will see it on a real data that it will make sense. Yes, Aditi, your question.
Part of the label 1 that is coming with games outside, that is also a error that it is giving, right? Because games outside was together.
No.
Children are playing games outside.
No. Let me explain. The thing is that this 1 means it's a positive sample and 0 means it's a negative sample. Now, okay, now the data, somehow some amount of garbage has gone into it, saying you see the same combination of words, it is considering both as positive sample and negative sample. So the data formation has not been very accurate. Otherwise, I would not have this situation.
Right, because playing R is also together, so it should also be either right.
It should be a positive sample.
Positive sample, yeah. Okay.
So, but when we do this on a real data set, we will not have this kind of problem. Yes, Srividya.
Okay, if this is a general question, so if we the actual model that is completely word trained should have a tremendous amount of corpus, right? So we are doing a very small set, right? Is that correct?
This is minute, not only small, infinitely small, right?
Okay.
Because actually,
so then how do they build the corpus? Because here we gave 2 sentences, 3 sentences. Do they take all the sentences from the internet or few books, 100 books and things like that and how do they do it?
Of course, they took the, like for example, what initial version of ChatGPT, they took the entire Wikipedia, entire Wikipedia. Then also they took book 1, book 2, book 3, book 4. What is book 1? Book 1 is all the unpublished books which is there. So that is a huge corpus. And similarly, I have book 2, which is unpublished books. So all that was freely available to them. Wikipedia, of course, contributed to the development of ChatGPT. They got money for that. And that is why they give their corpus. So the huge amount of corpus. Now you see that you understand by now that the amount of embeddings that I create, that forms the basis on which how powerful a large language model is going to be, right? I will discuss more about it later on, but you can take it as a thumb rule that the amount of embeddings that I have that determine how powerful my large language model is. That is the strength of its understanding. Now, we are talking about large language models in modern world, which have got understanding of 1.5 billion or 3 billion or 5 billion parameters. You must have heard these words, heard these statements. I have a LLM which has got 3.5 billion parameters. So when you are creating this 3.5 billion parameters, you can understand how much amount of input you are giving to the model so that it can produce 3.5 billion parameters. Correct?
Yeah. Okay, sir. Thank you.
Yeah, who is the other one who has raised the hand? I cannot see the name, please. You can speak.
Partha, it's me, and I'm not asking a question. I'm just noticing, a cliche that Wikipedia has actually taken so much of money from whatever LLMs for when they provided data to them, and they ask us for $5 every time that we
Yeah.
are poor. Please give us money.
No, just this is just a by note. Nothing, not that I'm bragging or anything like that. I started using Wikipedia very heavily only after about 2010, and then when I was using it, I had created an account also, and then I started contributing some articles for Wikipedia also around based on what I was learning, and some of the articles have been approved also on Wikipedia, but Wikipedia doesn't give names of the authors. You must know that, right? What do you call? Then Wikipedia started sending me notices that please contribute and all. Now, since about I think around about 2013 onwards, consistently every month I made a recurring payment of $10 to Wikipedia every month. So I'm contributing to them. But yeah, but it is not that they're really a NGO because they have a lot of source of earning money, and but they require that money also because they have to feed all the people who. But they did not pay me anything, though I submitted articles and it got printed. But they require that money for a lot of reviewers and this thing, that thing, and all kind of stuff.
I found that Wikipedia is not very reliable many times, so I've kind of restricted my use of Wikipedia very much.
No, I though I contribute the money, I don't use Wikipedia. I must have not been using Wikipedia consistently for last 3-4 years because Wikipedia is, especially as long as it is scientific articles, it is not a problem to use Wikipedia. But moment it comes to anything, a judgmental article or a historical article, Wikipedia is very unreliable because it is very heavily leftist. So that is why when I search for any historical content or as long as it is scientific, as long as it is factual like geographical content or it is a scientific concept, Wikipedia is fine to understand and the explanations are quite good. But when it comes to something controversial like even a simple thing like a history of Indian mobs or something like that, and it is very, very controversial. They are not accurate. So I stopped using it for that. Okay, nevertheless, from this diversion, let's come back to our discussion. So now you understand how this FastText algorithm is getting trained, right? After, though it is not giving a very consistent result, but nevertheless, we understand the network architecture and how to train the FastText algorithm. Now, and one more thing we have solved is that right now, because we are going by the subword tokenization, we don't have a problem of out of vocabulary issue. And also it is not creating tokens for every word. It is creating tokens only for, it is not creating embeddings for every word. It is only creating embeddings for the root words and the subwords. So with this power, now we can build applications around it. So I will show you one application which I will build around it. And this is basically a sentiment analyzer. Now, sentiment analysis, you understand that I have to understand the language. And this is a very powerful application because every organization almost requires to listen to its customer. That is what we call as a sentient organization. Sentient organization is the organization which listens both internally and externally. Internally means what? It should listen to its own employees. What are they talking about the company? And it should listen to that consistently. And it has taken... it takes internal feedbacks. Also a lot of companies, they do illegal, not correct things like scanning emails and scanning messages, etc. But nevertheless, the company has to listen to itself. And similarly, it is more transparent on the outside part because every company has to listen to its data outside the company, like what are the customers talking about it on social media and things like that. And companies constantly are monitoring that. And there are some companies like Hindustan Lever, not Hindustan Lever, Unilever in UK, which has gone to the extent that it collects all the customer feedback regarding its products from the social media. And based on what the customers are talking about the product on the social media, their design teams designs the products. They alter the design of the product. So it's a very robust system what Unilever has created. Okay. So any of your organizations doing something like this? Because this is not really LLM, this is something of a application of AI. So any of your companies are listening to your customers via social media? No?
I'm not aware, Partha.
No, not yet.
But this is a stage of maturity of your organization. This is one of the low hanging fruits, but a very powerful application which you can do because and the thing is that um, uh, the world has moved from talking to listening, right? So far companies keep on talking that I achieved so many orders and that's why my share price should go up and all this kind of stuff. But that is not the right way anymore. The right way in the modern day is that the organization should listen. What are the customers talking about them? And that is what we call the future organization, that is sentient organization. In case you have not come across this term, just research this term. This is very vital for creating a sustainable organization in the future. Sentient organization. If you want to understand this concept very clearly, you can read my book, Strategic Management and AI. I have explained how exactly to make a sentient organization. Nevertheless, okay, let's move forward. So I'm creating a sentiment analysis model. So I take my data from IMDb. I can utilize a generic data like IMDb and create a multi-purpose sentiment analysis module, because from this data, what I will do is that I will understand the English language, and this data is very huge, about 60,000 or 50,000 data points. And if I train over so much on the English language, it can understand which words are contributing to positive sentiments and which are contributing to negative sentiments. Now, this is a labeled data, so every feedback which is recorded in this IMDb database is labeled as a positive comment or a negative comment. So that is the advantage of this data set. We use it for many purposes. So let me just take this data set. I will show you one more application also which I have developed for commercial for Novartis. So you will see the power of such kind of systems. Okay, the data set is, now you see here that, okay, there are 25,000 training data and 25,000 test data. So this is the data which I have. Now I do some basic cleaning. We will not, like I discussed last time also, we will not do much cleaning. So I just clean the data and I label it according to the way Hugging Face requires it. This is the positive label, this is the negative label. So if I do that, so then if I train, let it create the training file where it has to create these labels, the positive label and the negative labels. I will show you that. So test file also I clean and I pre-process. Okay. Now you see here, this is the review comment, and this is labeled as negative. Okay, similarly, this is a review comment and this is labeled as positive. So this is the way the data is required for training my model. Is it clear? There should be no doubt so far, right? Correct assumption? Just give a nod so that I know you guys are awake. Okay. So now I train my model. I'm creating embeddings of how much size? What is the size of the embeddings I'm creating?
100.
100.
Correct. I'm creating embeddings of 100 size, and the subword tokenization will be 3 to 6. So it is here. This is the parameter.
So word n-gram is like we assume that 2 words at a time, right? That's the n-gram for words.
Yeah. And 2 gram, two words together means bigram. 3 words together is trigram. 4 words together is 4 grams, and like this. See, you must understand that when LLMs are trained, first of all, they take a huge amount of data, a huge corpus, and then on top of those corpuses, they make huge amount of n-grams, like 20 grams, 30 grams. That is why so many parameters you get in the LLM models. So I saved my this thing. Now I evaluate on the test data. So let us evaluate and check what is the confusion matrix. You see here, it is very effectively it has learned. Do you notice how many corrects it is getting and very few mistakes it is making? Are you convinced about that?
Yes, Partha.
Okay. Now if I make a prediction model, you see that okay, this is the review what I gave as my input. The movie was brilliant emotionally, and this says the predicted label is positive, and the probability is 100. With so much confidence, is telling you that this is a what do you call positive feedback. And if I give this, I found the film boring, predictable, and far too long. It says this is a negative feedback, and the confidence is 100%. So do you think it is working? Look at this.
Yes,
Yes, sir.
last
Yes.
one does not seem to be working.
No, this is
100%.
ambiguous, but still
Yeah.
it has got it quite right. It is ambiguous. Story started slowly. It paid more attention to this rather than this, right? It did not pay too much attention to this part, but it paid too much attention to this part. That is why it has got it wrong. Now, here's an interesting thing which you may want to understand regarding LLMs is that what the LLMs have got a defect in them is that they pay too much attention to the words in the beginning and in the words in the end. Okay, so the words in the beginning they will pay too much attention to it, and the words at the end they will pay too much attention to it. And this is nearly around about 90% plus. Okay, 90+% attention is given to these words. This is a generic problem which we are trying to solve across all LLMs. Okay, but this can be indicated to you that how to talk to LLMs, right?
One more sample, sir. Like that, just reverse the last sentence. The movie became deeply engaging by the end, though it started slowly. And see what the model.
Good suggestion. Good suggestion. Let us check this. You see? Are you convinced?
Yes. So it is not made for verbose people like me.
Okay. So like I was telling you, the problem with these LLMs is that they consider the beginning and the end words with a high amount of interest, but the words in the middle, which are there in the middle, they pay very little attention to that. It is as low as 18%. So this can be an indicator to you that while dealing with current LLMs, you must keep this in mind so that when you want him to pay attention to certain things very deeply, you put them at the very beginning or at the very end. Don't put them in the center. Then because he doesn't have too much context of things which is there in the center. Okay.
Right, but in the real world, it is not. We don't control what is being fed to the model, right? So there is possibility of error.
That is where if you have this insight into how LLMs work internally, you can control the way you talk to them, right?
So there's a concept called reinforcement prompting.
Yeah.
So this is
But
precisely why you do that.
this is going to be an important insight in my capstone project, Parth.
Very good. Very good. Okay. So, you saw that I can make a sentiment analyzer. Now I will show you one more application which I developed. This is something which I developed. 1 minute. You see, this is something which I developed for Novartis. So I will show you that application. So this is all. This has got one step further actually. Now what I have done is that not only created the embeddings, but I have embeddings are nothing but vectors. That you all understand by now. What I've done is that after creating the embeddings, I've stored the embeddings in a vector database. Okay. And this vector database I have utilized from Facebook. So this is called FICE. This is a vector database. So I stored the embeddings in a vector database, and then I queried the vector database whenever a new subject was to be researched by the system. Okay, while it will take just 1 or 2 minutes to build it. No one uses these applications, though I have planted them here. Let me, by the time, share this application with you guys so that you can try it yourself also. Yeah, now I got the link to this chat. Okay, let it come up. Just what? Okay, what it does is that actually Novartis gave me a huge set of data regarding their clinical tests. Now, clinical tests, you understand, for a pharmaceutical firm is a very expensive exercise. Before, like when they develop a drug, they have to get the clinical test done, and only when the clinical test results are good does the government give them the license to sell the drug in public. Now, they have to set up the clinical test. Now, clinical test setup requires a lot of effort because they have to find patients and of a particular type, and then they have to make two groups at least. One is a control group and one is a control group and one is a normal group, and then they have to administer to one of the groups and they have to observe both of them. So this takes a lot of time, and the planning itself takes a huge amount of time. So Novartis's purpose was that now I am giving you the historical clinical test which has been done by Novartis. What you do is you make a machine learning model so that when I have a new clinical test to plan, you tell me what are the clinical tests which are most closest to the current clinical test which I'm planning. So that what I will do is that I will study those particular clinical tests and I will understand how it was done for success in the past, and I will replicate as much of the formula as possible. So this saved Novartis millions and billions of dollars actually. Okay. So now this is the system where I can give a query. Normally Novartis will give a huge query that I want to do this, do that, and all kinds of, but for our purpose, we don't understand so much of medical stuff. So if I give a particular disease, you give me any disease name, any disease name, you tell me.
Infertility.
Infertility. Okay. If I take this and I'm telling him, find me all the clinical tests which are appropriate for this. So you see that he has found the clinical test, and you may not understand so much of medical terminology, but look at the word cloud. Does it suggest that this clinical test which I've retrieved is for infertility?
Absolutely. Wait a couple. Yes.
Look at this. It has found 5 of them. Tell me whether they all relate to infertility or not.
Yes, Parth. Absolutely.
Okay. So did it understand my query and did it get me the appropriate data?
Yes, it did.
So it is able to understand my language, right? You want to try one more? Just one last try. Give anything.
Alzheimer's.
Alzheimer's. Spelling is correct, right? Yeah. Now, look at this.
Yeah.
Dementia.
It is dementia, everything. Yeah.
So it is understanding, right? Slightly, this is fine.
Maybe they have not done a lot of studies on
Alzheimer, yeah.
Alzheimer's. Yeah.
Yeah.
So for this, Partha, you have used FastText.
I've used FastText, yes.
Okay. Yeah.
Okay. So are you guys convinced about FastText?
Mm-hmm. One quick question. So
Yeah.
now that we are seeing different methods of making the model, so how do I decide what is required for what?
Yeah, good question. Now, for example, why I'm giving you so much detail regarding what is the problem being solved by each model. Okay.
Mm-hmm.
Now, I will give you some examples. For example, Spotify had the problem that they wanted to find out what are the songs to recommend to their customers. Okay, that is the problem which Spotify had. Now, in that context, what Spotify thought was that what they will do is that they will treat every song that a customer plays as a word. And the song which the customer plays will be as a word, and the playlists what they create, the customers create, they will be treated as sentences. This was their strategy. Now, once they had this strategy, which model do you think they found the most suitable for creating for finding the language similarities?
FastText.
No. No.
Just a guess.
Yes. No, they use skipgram. Skipgram was the most effective model. Okay. So what I'm discussing with you guys is not an ancient technology. This is all latest technology and they're being heavily utilized. Okay. Spotify's entire model is based on skipgram. Similarly, Alibaba, its recommendation system is also purely based on skipgram, not on other advanced models which we're talking about right now. And right now we have come to the stage where we are able to decide morphology. But why do they use skipgram? This motivation should be very clear that morphology in songs is not important, right? Would you agree with me?
Yes. Yeah.
The morphology in finding song recommendations is not important. That is why I would not go for FastText. Instead, I can very easily stay with skipgram. Yes, Aditi.
Is it also true for other recommendations in I'm not able to name the platform, but
for example, Amazon product recommend.
That is what I meant. Yeah.
Yeah, Amazon. I do not know what technology they use for reading their customer reviews. I am not aware of that. But their Amazon product recommendation is not based on language study. It is based on a technology which is called what is it? 1 minute. Again, some words come to my head and don't come to my mouth. 1 minute. I will tell you. It is based on a technology called market basket analysis, MBA. Okay. So maybe sometime we will discuss that. That's very interesting.
So now Amazon and Alibaba are the same kind of websites, correct? So why would a skipgram be better suitable for Alibaba than Amazon? Like, why? What does Alibaba do with the skipgram?
Alibaba, it understands the products, because Alibaba's the basic thing between Alibaba and Amazon is that the number of products which Alibaba sells is far greater as compared to what Amazon sells. This may be interesting for you guys to know, but that is the reality.
Oh, okay. So the model will become huge, possibly. That's why they use the script.
Yeah. It is not practical to do an MBA for Alibaba, but it is practical for MBA to be done for Amazon. And Amazon MBA also is a very heavy algorithm, but we use a clever trick which is known as the a priori algorithm. And with a priori algorithm, we can prune the complete training data to a very small set, and that's how it becomes practical. Okay.
I'm not sure this is the environment right now. So I just want to check on how do we do a QA on this LLM models that we are designing, right? What are things that we need to factor in? One is development. We are looking at, a lot of development happening right now, but how do I make sure that, the QA process is in place so that I can make sure the LLM that we are developing is went through proper quality checks and stuff?
Okay, I will spend a lot of time actually. I will spend maybe 2-3 sessions on how to evaluate a LLM. That is very important topic. So will you wait for that?
Yes. If you have factored that in your course, that is good enough.
Yeah, because what do you call doing a audit on the LLM that you develop or you want to use is very important thing, because like as long as you're a casual user, it is okay to just use the LLM and get along. But if you're a serious user, especially when you have internal knowledge of the LLM, you must know precisely how to evaluate a LLM. So I will spend a lot of time on that.
Partha, that will be in addition to the 9 sessions that you have planned, right?
No, this is only word embedding. We've just got started. We've not even come to the LLM part.
Okay, sounds good.
Yeah.
Happy about that.
No, we've just started. We're getting now word embeddings. Word embeddings is the first layer of LLMs. Okay. Then we'll have to get into the transformer. We'll have to get into the attention mechanism. We'll have to get into things like we will control temperature. Temperature basically controls how creative or how sedate LLM is. Like, if I set the temperature low, then the LLM will become, if I set the temperature high, the LLM will produce highly, creative contents. And if I set it low, then it will be going according to the basic training which I've given him, so that it is more consistent as compared to more creative. So all these things we will discuss.
And go ahead, Aditi.
No, I was just saying looking forward, that's all.
Yeah.
Thanks.
Okay. No, I was going to ask Partha, are there any small projects that I can build on the side, so that I see your code, but I'm not able to completely perceive it mathematically, so is there anything, that small exercise or anything that we can do on the side?
No, first of all, everything what I do, I make it open. Now you notice here,
okay.
This I've given you the link to this website, though I have a copyright on this, but so don't utilize it for making commercial applications. That's all, without my permission. But the code is there, so you can take this code, you can modify this code, you can learn from this code, and develop your own applications based on this code. I do not hide anything from the public, so all my creations, they are available publicly to you. So you can when I'm giving you these links, you can utilize that, and you can do any project that you are feeling like doing.
Okay, let me, I'm not there yet, I believe, for the bigger one. Maybe I'll start with a very small one.
Yeah. Okay. That gives me a good idea that maybe I should make a book on building applications. I already have a lot of applications, so I will not take much effort to create that book. I will just put this code and explain it, and it will become a book. That's a good idea. I will do that.
Right. And Partha, if I go way back, I just people like us actually also struggle with learning Python. So doing a small bit of coding in Python is a different story, but creating the kind of code that you show us is an entirely different thing. So how do we reach there? I'm actually personally struggling with that.
Okay, well, good. Now, first of all, the realization that you must know Python is a very big realization, and it is non-negotiable in today's world as far as any kind of manager is required. Manager is what do you call it, involved in the modern data world. Data world. Okay. So I will give you a very good resource to learn Python programming. This is directly from Harvard. This is a very, very, very popular program from Harvard, and it is there are, I think, millions of people who have taken this program. So enroll for this. This is free also. So just enroll for this program and go through it. It will not take much time also, and you will learn Python very effectively.
Thank you, Partha. This is really appreciated.
Okay. This C50 is a very good series which Harvard started. Actually, it was started in MIT, and then Harvard is taking it forward, and it is very useful. It is free, but at the end of the show, if you find this to be useful, contribute about $20-25 to them.
Yeah. Yes.
Okay, guys. So I will stop here tonight. I hope you found this useful. Now, I will leave before we disconnect. Now, we have solved the morphology problem, but then we have still got another problem in our hand. That is, so far you noticed if you notice that for every word, I'm making one vector representation. Have you noticed that?
Yes.
Yes, Partha, yeah.
Okay. Now this is a problem. Why? Because in our language, we use many words in different contexts. Like, for example, take the word bank. Now this word bank, if I have a single representation for this, it is a problematic because sometimes I refer to bank as a financial institution. Sometimes I refer to bank as a geographical location, right? So now if I have to represent both this different utilization of bank, I cannot have both of them pointing to the same vector representation. I can never achieve my goal of effectively treating the word bank. So now what I require is based on the context in which a word is utilized, I must have different representations. So now, so far, what we have done is that we have got static representation for every word, but this should change, where I should have dynamic representation for every word, and every dynamic representation should be based on the context. So that is our next problem. So we will tackle that in the next session when we discuss the algorithm called Elmo. Okay. So hopefully you will join me and we will have a discussion on that.